I'm not sure about play around. If you have a little schema or a little database instance in which you can build things and destroy things at will, then go ahead and do that. Otherwise, you might just want to look at the examples and make sure that you understand how they work and what they do. Oracle does offer an alternative to DB to execute immediate for executing dynamic DDL statements. The DBMesh utility package has a built-in called exec DDL statement, and it will simply do the same thing as execute immediate with a string. And the statement executes under the authority of the schema from which the procedure is called. So even though the package is owned by sys, don't worry, you're not going to be executing the DDL statement under sys's authority. And other than that, it's pretty much the same thing. I can simply say exec DDL statement, create table, drop table, etc. When I run the script, I'm going to get an error. Notice missing left parentheses. Note my create table statement is not complete. I don't specify my columns. And so the point I wanted to make here is that if I execute my DDL statement dynamically, I'll get the same error that I would if I was executing it statically. It will just propagate it out inside my Plsql block. I can trap the error. I can do something with the error, but it will be the same error that I would have gotten otherwise. Okay. Let's talk about some common problems or complications with dynamic DDL. As I mentioned before, it always performs an implicit commit, so make sure you can account for that. You'll be dealing with that in your code if that makes sense. Otherwise, you might consider using an autonomous transaction to narrow the scope of that commit, the propagation of the commit. I'll be talking about that more under best practices for dynamic SQL. Generally speaking, you want to use dynamic DDL with great care, since a DDL change not only performs a commit, but can also cause a ripple effect of invalidations of your program units. Any database object dependent on an object that you changed with dynamic SQL will cause invalidations. Second of all, and this is much more subtle, you might get insufficient privilege errors. In other words, just because you can do something as static SQL, a static DDL inside your schema, doesn't mean you can do it as dynamic DDL inside a stored program unit. Because when you execute inside a stored program unit, sorry, this should say inside, not outside your stored program unit. If I create a stored program unit, a procedure that executes a DDL statement, then I will need directly granted privileges for that to work, or compile my program unit with invoker rights. Lots of details there. Let's take a look at a script that verifies all of this, demonstrates it. So my file, DDL insufficient privileges, first of all, connects as my sys account and doesn't allow Scott to create tables. So I revoke create table from Scott. And I'll also revoke a role called create table in case it's there. I will make sure that Scott can create procedures. So Scott cannot create tables. Okay, then I'll connect to Scott and I'll see, can I create a table? And I'll try to do it with static DDL, and I'll try to do it as dynamic DDL inside a Plsql block. Then I'll go back to my sys account. I will create a role called create table, which has the ability to create a table, and I will grant that role to Scott. I'll go back to Scott, and I'll see if I can create a table with static SQL. I'll see if I can create a table with dynamic DDL inside an anonymous Plsql block, and then I'll create a procedure that does the same thing, create a table dynamically, and I'll see if I can do that. Now, this procedure is actually an authID definer rights program, which means that it's compiled and executed under the privileges of the owner of the program, Scott. And then I'll try it again with invoker rights. So I'll recreate the procedure with my authID set to current user, and now it runs under the privileges of the invoking schema, and role-based privileges are allowed, and I'll see if I can create a table. And finally, I'm going to go back and grant a directly granted privilege to Scott. Then I'll go back to Scott, and I'll try to create the procedure even with its set to authID definer rights. That's a lot. Let's try it out. So what I've done is start up my SQL Plus session. I'm going to grab all this code. I'm going to run it inside SQL+. I've created a spool file. Let's check out the spool file. Let's remember what the spool file name is, dynamic DDL. Let's take a look at what happened. Okay, so I revoke create table from Scott. Then when I connect to Scott, when I try to create a table, whether it's directly inside SQL+, whether it's dynamically, I cannot do it. Insufficient privileges. That makes sense. I have no privileges to create a table. Okay, I go back to sys and I say, all right, let's let you create a table, but only through the create table role. So role-based privileges. No directly granted privileges to Scott. I go back to Scott. Can I create a table? Absolutely. Right inside SQL+. Can I create a table with dynamic DDL? Yes. No problem. But notice this is a top-level anonymous block. And the problem then is when I create a stored procedure with authID definer, which is the default inside Plsql. So I create a stored procedure and I try to create a table. Then when I try to do that, I get insufficient privileges. Because with definer rights programs, which is how most of our programs are defined, with definer rights programs, the program has to execute only with directly granted privileges. No role-based privileges are allowed. So I don't actually have the privileges yet to create my table. However, if I change my definition to an authID invoker rights current user, then Oracle will let me use role-based privileges and I can create the table. But notice it says name is already used by an existing object. So it didn't actually create the table, but clearly it could have. It simply was not able to because the table already existed. Finally, I'm going to go back to sys. I'm going to say, okay, Scott can create tables with a directly granted privilege. I go back to Scott. I create my procedure, create table proc, authID definer rights. And then when I create my program, when I try to create my table, it says, no problem. You were able to create the table. So there are clearly lots of things going on here. Role-based privileges, directly granted privileges, authID definer, authID current user. We're not going to be getting into invoker rights in this series. You'll want to take a look at my managing Plsql applications lesson series for that, for details on that. But the point is, as soon as you work with dynamic DDL, you might encounter a situation where the process, the statement that you wanted to execute, let's go back to the code, you find that you can do this. I can create my table inside my schema in SQL+ or wherever else in Toad, no problem. But when I try to use it, when I try to do the same thing inside a Plsql program unit, I get an insufficient privileges error. If you find that happening, it works outside of Plsql, but inside Plsql it doesn't work, then chances are the problem is you need directly granted privileges, or you need to change your program to use invoker rights, authID current user. So that's the thing to look for when you run into insufficient privileges. Let's finish up by taking a look at executing simple DML dynamically. There's nothing to it really. You just execute the string, same as dynamic DDL, but it's even simpler here because you don't have to worry about as many side effects as DDL. And after you execute the string, if you'd like, you can check the contents of SQL%row count to determine the number of rows modified by your statement. So this attribute, this implicit cursor attribute, will apply to the most recently executed dynamic SQL statement as well. Here's my example. I execute immediate. I construct my dynamic string, my DML statement. I have a dynamic table name, but I have no placeholders, no colons. And then I'll take a look at the value returned. Let's try it. Same thing I just showed you. Afterwards, I'm going to roll back because I don't want to keep this change in place. Run my script, no errors. And I updated 107 rows. Now let's see. Why is that? Because the employees table has 107 rows of data. So it updated every single row in the table as I asked it to do. So that's simple DML. Just construct the string, pass it the string, execute it, and then take a look at the impact. Either an exception was raised, or you can look at the number of rows modified. Conclusions. Dynamic DDL is a very powerful tool. There's so much you can do, but use it with care. There are so many potential dangers, the ripple effect of invalidations, privileges issues, implicit commit. The simplest DML, in other words, no binding of variables, can be handled very simply. And in fact, also the dynamic DDL is very simple. The actual execution of the statement is a no-brainer. The impact of the execution of the statement and the construction of the statement is where you run into complications. But simplest DML is handled very, very simply. It's also quite rare. It's unlikely that you're going to have very many DML statements that you're executing dynamically that do not have or should have bind variables. Most of them will need and should have bind variables, but in this case anyway, it's simple enough. Next steps. Download the demo zip if you have not already done so. Unzip those files and go back through this lesson. Check out each of the different files I demonstrated and showed to you. There's a lot to cover here. Make sure you understand both how to write the execute immediate statement, but also the complications you can run into, especially insufficient privileges. And then move on along and learn how to execute dynamic DML statements that have bind variables, dynamic queries, dynamic Plsql blocks, method for dynamic SQL. Lots and lots to cover in dynamic SQL. I hope this lesson was